Hello guys, in the previous lecture we have learnt about what is the slope of a line, which is tan theta, where theta is the inclination of the line, and we have seen why we define slope as a tan theta, and again how to find the slope of a line using 2 points, any 2 points of a line. So we got slope equal to y2 minus y1 by x2 minus x1. Yeah, and one more thing we have seen in the last lecture is conditions for parallel lines and perpendicular lines. For a parallel lines, the slopes are equal. We have seen why, because the inclinations are equal for both the parallel lines. For perpendicular lines, we have seen that product of these two slopes of these two lines equal to -1. Today, we are going to learn about the angle between the two lines. Let's say if you see any two lines on the x-axis, either they intersect or they are parallel. We know this. If they are not parallel, they will intersect at some point, at any point, at somewhere. Let's see. Let's say this is a line and this is a line. These two are not parallel, but these intersect at some point, which is not at some point they will intersect. If they don't intersect, then they are parallel lines, where this distance between these two lines at any point is same. Okay, now let's say a line L1 and other line L2. Other line L2. Yeah, this is line L1, this is line L2. We need to find the angle between these two lines. See, there are two angles between these two angles. One is this, which is acute, some theta, and the other one is, let's say, phi, which is nothing but 180 minus theta, because these both are supplementary angles. So the angle between these two lines are either theta or phi. If one is acute, other will be obtuse, because those both are supplementary. Let's say the inclination of line L1 is theta 1, the inclination of line L2 is theta 2, and the intersection point is some P, and these two intersections with the x-axis points are Q and R. So we need to find angle theta in terms of slopes of these two lines. So we need to find angle between these two lines by using the slopes of these two lines. As we know the inclinations, so we will get the slopes. So if you observe, from triangle PQR, angle PQR equal to theta 2, angle QPR is nothing but this angle, which is equal to theta, because these both are vertically opposite. Vertically opposite. Angle QRP, which is this angle, which is nothing but 180 minus theta 1, because theta 1 and this angle are supplementary. Theta 1. We know sum of all three angles in a triangle are equals to 180. That implies theta 2 plus theta plus 180 minus theta 1 equal to 180. 180 gets cancelled. That implies we get theta, which is the angle between these two lines. One of the angle between these two lines is equal to theta 1 minus theta 2. Now we need to find theta 1 minus theta 2. Say, for line L1, what is the slope M1 of the line? Tan theta 1. For line L2, M2 equal to tan theta 2. Now we need to find angle between these two lines, which is nothing but theta, which is equal to theta 1 minus theta 2. So tan theta equal to tan of theta 1 minus theta 2. From trigonometry, we know that tan A minus B equals tan A minus tan B by 1 plus tan A into tan B. Similarly, tan A plus B by 1 minus tan A into tan B. So tan theta equal to tan theta 1 minus theta 2. So tan A minus B, use the tan A minus B formula, that plus tan theta 1 minus tan theta 2 by 1 plus tan theta 1 into tan theta 2. We know tan theta 1 is nothing but slope of line 1. Tan theta 2 is nothing but slope of line L2, which is equals m1 minus m2 by 1 plus m1 into m2. So tan theta equal to m1 minus m2 by 1 plus m1 into m2. Yeah, no, it's not our it. Tan theta equal to m1 minus m2 by 1 plus m1 into m2. Now, if m1 minus m2 by 1 plus m1 into m2 is positive, so you have given two slopes of two lines and you calculated m1 minus m2 by 1 plus m1 into m2. If it is positive, what does that mean? Which is nothing but it's a tan theta. So tan theta is positive. That implies tan theta is positive. As tan theta is positive, that implies, as we know, theta lies from 0 to 180 only. So tan theta is positive. That implies theta is acute angle. We have seen the tan theta curve in the previous lecture. See here, for 0 to 90 degrees it is positive. For 90 to 180 it is negative, which is obtuse angle. For obtuse angle these are negative. For acute angle this tan theta is positive. Okay. If other case, if m1 minus m2 1 plus m1 into m2 is negative, tan theta is positive. So the angle phi, which is 180 minus theta, tan phi is negative. If theta is acute, that implies phi is obtuse. Similarly, if m1 minus m2 by 1 plus m1 into m2 is negative, that implies tan theta is negative, which means tan phi is positive. Why? Because see, theta is theta 1 minus theta 2, phi is 180 minus theta. So tan phi equal to tan 180 minus theta, which is equal to minus tan theta. So if tan theta is positive, tan phi is negative. If tan phi is positive, tan theta is negative. That implies theta is obtuse, phi is acute. So to generalize these two cases, we can say the acute angle theta between two lines L1 and L2 whose slopes are M1 and M2 is given by this equation. Tan theta equals modulus of M1 minus M2 by 1 plus M1 into M2. Here we kept modulus because if M1 minus M2 by 1 plus M1 into M2 is either positive or negative, if you do modulus you get a positive quantity, so theta is acute. So we can say the acute angle between any two lines with slopes M1 and M2 is given by tan theta equal to modulus of M1 minus M2 by 1 plus M1 into M2. So this is the final result. Thank you.